Alright guys, today I want you to start in your notebook. I want you to summarize these things here. I want you to summarize individually and then discuss as a group. And then I would like one sheet or even like a picture of someone's sheet with the pros, cons for each category listed out, sent to me, brought to me so that I can check to make sure, because the class today was missing a couple that we needed to add. So take some time right now, pause the video, individually come up with pros and cons for each one of these categories, and then discuss as a small group. After you've identified all of them, amongst all of your ideas, either take a picture or write down a copy of it and email it to me, or come bring it to me so that I can check it over. So pause the video and do that. All right, take the sheet that I gave you today and divvy up the roles here. So you have desalination and reverse osmosis. One person is going to be a supporter for desalination, one person is going to be an adversary, one person is going to be a supporter for reverse osmosis, one's going to be an adversary. You're each going to do a short research on it and what arguments would that person use to defend their side of the case. So what I mean by a supporter, that means they are for desalination or they are for reverse osmosis. Obviously, an adversary is someone that's against it. So you got to find arguments for each one. And then I would like you to share out as a small group what your findings were. And then once again, I would like, there's a reason I gave you an extra sheet, is I want you to summarize on the sheet what everybody came up with, so that I can then give you feedback to make sure you have everything that is necessary. So pause the video, split up the roles, and decide who's doing what. Do your research, and then share out as a small group. We did this in class as a more like a debate setting, so you can do one or two things. You can either have the debate on your own. I did like last time when you guys recorded it, was interesting. It was a debate between, obviously, the desalination supporter and adversary, and a debate with the supporter and adversary for reverse osmosis. It wasn't like which one of these is better to do. Then what I had them do after they did their small debates within their specific topic, I had part of the group come and share out the evidence for the other water type or water availability type, so that everybody had notes for each category. So you can choose what you want to do. You can just do a small group debate overall, or you can do the two different categories separated and do a recording of it so I can see it. It's up to you guys. You guys can decide what you want to do there. So pause the video, decide what roles you're going to take, and do your research and have your discussion. So just really quick, you've now done your mini debate on desalination and reverse osmosis. Just wanted to show you guys how these two things work. The first one is the desalination, which is it's pretty much a distillation process where they're evaporating water. They collect the fresh water and then they use fresh water. Reverse osmosis has a very tiny filter. We did discuss in class that this technology is actually no pun intended, trickled down to other uses. They now have this thing called the life straw that is a type of reverse osmosis where it has such a fine screen that you can actually take the straw, put it right into any water source, and drink from that water source wherever it may be, and it filters out the pathogens and pollutants so that you can have it. This has been a really important source of fresh water for countries that have polluted water or don't have the availability to build and have the infrastructure for water treatment plants. So just wanted you guys to see how that works. Reverse osmosis has the filter, but actually has this huge amount of pressure that's put on it to squeeze that water through to the other side, and that's how reverse osmosis works. You guys should have already talked about these things, so I'm going to skip over this. So problems with the water supply in the United States. This is just straight up notes. Some of the issues in the United States that we have is we have fresh water in wrong places. We get a ton of fresh water in the eastern United States, and when you have all that fresh water in eastern United States, you end up having flooding and all this kind of stuff. And in the western part of the United States, we don't have enough water. And I just have on here the uses. In the east, it's mainly used for energy production and cooling and manufacturing, whereas in the west, it's mainly used for irrigation. Obviously, the west has a major issue where, the one thing that we need to understand is that in the west, that's where most of our agriculture, when we talk about vegetables, that's where it comes from. Unlike the Midwest, where you have lots of grains, we get plenty of rain in the Midwest, and that supports our grain growth. But in the West, and especially in California, they use all that irrigation to grow crops that need a high input of water. So some of the other serious problems, just to kind of looking at east versus west, the West has a shortage because they have low precipitation. Think about the fact that in the West, you have the Rocky Mountains, so you get Rocky Mountains and the High Sierras, so therefore you get a major rain shadow problem. And if you think about the West, a lot of it is desert-like areas, and because of those desert-like areas, the soil can't hold on to a lot of moisture, so therefore and because it's that sandy and hot, kind of arid environment, you get a lot of evaporation. So moisture that they do get does not stay in the ground, or it doesn't have time to infiltrate into the ground. In the east, we get the flooding. We occasionally get urban shortages, and sometimes late summer, if it's a dry summer, you end up with shortages, just like, 2-3 years ago when we had the drought here in Pewaukee, and they couldn't water the football field and those type of things. But one of the main issues in the east is that a lot of the freshwater sources are polluted because of the high population of people in a small area. I just want to show you how water is actually used here. And this is kind of globally, not specifically the United States, but people don't realize how much water actually gets used. One automobile can take up to 106,000 gallons of water to produce. Cotton is a very delicate crop. It needs a lot of water to produce. And so you can see how much water is needed for a kilogram of cotton. So also producing aluminum. This is actually, when it talks about producing aluminum, that's actually from raw materials, so from mining all the way to a usable product. You can see 2,800 gallons for 1 kilogram. That's 1,000 grams of aluminum, which is not very much. It needs that much water. This is why actually recycling aluminum is really important, because it takes less than half that amount of water to produce 1 kilogram of recycled aluminum. We'll talk about later on, we talk about resources. We'll talk about the energy that actually is used for aluminum as well. One thing that a lot of people don't realize is how much water is used for our food sources outside of crops and vegetables. And 1 kilogram, again, 1,000 grams, not very much. You're thinking like maybe 2 burgers, 3 burgers, depending on how big you make them. That is taking 1,900 gallons of water. And the reason that people don't think about it is they have to feed those steer and that beef cattle crops. And so the amount of water used for crops is tied into how much water it takes for a kilogram of beef. And you can see the rest of them. When we talk about rice and then corn and all these things, this will come more into play when we talk about food resources and farming in upcoming units. You can see that your diet has a major impact on what we already talked about earlier in the year a little bit, the amount of energy that's used, but also the amount of water and just resources in general. So reviewing things. Water is constantly being recycled in the hydrologic cycle, so we know that water is being recycled and it should refill and replenish, but are we using it faster than it can actually replenish? It's unevenly divided, so it's kind of crazy. Global, so I gave you some of the United States situations or issues we're dealing with. Canada has 0.5% of the world's population, but has 20% of the water. In reverse to that, China has 21% of the population and only 7% of the water. So, and they're talking about fresh water, obviously. This water shortages are going to intensify over time. We've discussed this a little bit. We know that as climate disruption or change takes place, it's where it's already dry will most likely get drier, and where it is lots of precipitation, there's going to get more precipitation. So what I want you to do right now is answer this question, pause the video as a group, and what actually causes water shortages. So pause the video, answer this question. So let's compare some of the things that you guys came up with to what I have on the list here. So what's causing it? We know that dry climate is going to cause it. We already talked about this before. We know that if you have a dry climate, evaporation rates go up. So that's something from back in our atmospheric and weather pattern unit. Drought is the one that people usually forget about. I mean, that's probably because I think it's so simple. Drought actually is defined as a 21 period, a day period of time without precipitation, or below 70% normal, and the evaporation is higher. Desertification. This is one we're going to get into again when we talk about farming, more so and resource usage, but desertification is also adding to these water shortages because as you lose organic material, that's what desertification is, so you have only the mineral part of the soil left instead of the organic material. It can no longer hold on to moisture, and that creates an issue. Water stress, so overusage of water is obviously one of the other major ones. We saw that with the Aral Sea, how drawing fresh water from a source can have a major impact both economically and ecologically. So here's your homework. You guys can start working on that. Remember, you need to check in those couple items with me. Once you have those items checked in, you're good to go. So I need you to complete questions, the guiding questions for 13.6, and read 13.7 for next class. Next class we'll finish up water usage and then move into water pollution. So have a good weekend, and I'll be seeing somebody, or at least an email from somebody, on those things that I asked you to check in with. So I will see you guys next week.